Hi everyone and welcome to my talk here for more programming tips and tricks. Hope you all had a great conference so far. Before we start, I thought we should make sure we're all on the same page regarding the terminology we're going to use here today in this session. Like, what is mob programming? What is a mob? Well, one could think of a mob as some form of organized crime, like the mafia, and mob programming being these bad guys creating software to steal your money. But that's not the case. We're going to talk about mob programming as an evolutionary step to pair programming, where you have 3 or more people sitting in the same space at the same time, solving the same problem using one shared computer. So as Becky introduced me, my name is Tynja. I work for a Swedish consultancy called Diabol. We help our customers in becoming more efficient in their software development process. We help them implement continuous delivery using lean and agile ways of working. I work as a developer and a coach myself, and this talk is about experiences I had from joining a development team where we use mob programming as the de facto way of working every single workday for over a year. So, a small disclaimer, I'm no longer part of the team, even though it might sound like that throughout the presentation. And I thought I should give you some context about the organization where we use this. It was a fairly mature organization in terms of agile software development adoption. I worked with 1 out of 35 development teams at the time. We had a microservice-based architecture with around 100 plus services running around in production. And all of our teams had end-to-end responsibility, which means that we as developers in development teams are responsible for coding, test automation, shipping it to production, operating it, being on call, and so on. No throwing stuff over the wall to another silo. So why am I standing here talking about mob programming? Well, we saw some great benefits, and I hope this will be inspirational for people who like to try out mob programming, or if you are experienced, to get some tips to help you along the way. So why did we start in the first place? Well, when I joined the team, at that time, most of the team was out at a local conference in Stockholm, watching a presentation at that conference about mob programming. And everybody got really excited and inspired by this and thought, why not try this out? But we were a little bit afraid, of course. What would our manager think? This seems like a crazy and controversial idea. Everybody works on the same thing using one shared computer. So we asked him, and we happened to have a great manager who told us that I don't really care if you're working solo, pair programming, mob programming, sit on top of each other. I don't really care. As long as you're productive, you deliver what you're supposed to, and you enjoy doing it, then you're free to do so. So we happened to have a couch and a TV in our team area, so we sat down there and started hacking away. We didn't really know what we were doing at first. We had no process, but we enjoyed it somewhat. We worked together, shared some knowledge, and we just thought we should give it a good try and not give up. I've heard a lot of people said, like, we tried mob programming one day, but it didn't really work for us, so yeah, we're just going back to the good old ways of doing stuff. But I mean, it's like, start to doing Kanban or whatever. You need to actually give it an effort. It's not something you buy off the shelf, apply it immediately, and think it will work out of the box. But sure, I've heard companies say we tried Agile, it didn't work for us as well. So yeah. So it's quite interesting to stand here and look back in a full year, like doing a retrospective on this whole process. And you might usually sound like that in presentations about success stories, that everything was fine and dandy, it's a straight road, everything was really easy, but that's not the case at all. It was a lot of twists and turns, ups and downs, and we had to work with this constantly in order to get better at it. So we had retrospectives every second week, and usually we had some part of the retrospective touching on mob programming, how we can make things that doesn't work better, and the things that are working good, how can we make them even better as well. So it was quite a muddy road at times. So I thought I should share some of the main pitfalls that you might encounter if you're trying out mob programming, and some of solutions or how we solve them. One of the first things you will probably notice when you start mob programming is that it feels like you're in the middle of a hen house. Everybody's just talking at the same time all over each other. Somebody has to brag about knowing the business logic the best, and in our case it was usually a hot debate about how to perform a certain refactoring in IntelliJ in the least amount of keystrokes. So entertaining and daunting, and I can understand that people get turned off after this, but it gets so much better when you start focusing on the flow. What's the problem we're trying to solve? What are we here to do? So, and if you're a lot of people, or 5 people, it's easy for someone to call a timeout if you notice the discussions are derailing. Like, let's get back on track, solving this particular problem. Maybe you can bite your tongue for 15 minutes for that urgent need of refactoring you notice in the source code, but nobody else seems to notice. And we noticed that agreements on coding standards and such, which usually also is a hot topic in some development teams, just evolved naturally. And when we worked together for a longer period of time, we noticed that the source code started to be like in harmony. You can no longer see that, oh, John wrote this method because he names his methods and variables particularly, or this person is sloppy with the indentation. Everything just looked nice and dandy, easy to maintain. But then the problem was, if you need to go back in time to see when a particular code change was introduced, you can no longer trust the author there, because you didn't know if that was the person at the keyboard or did we just happen to use that person's computer at the time we were programming. So traceability is important, at least for us, and we decided to solve this in a really simple way. We just add a convention that in the second line of each commit message, we specify the name of all the team members that were part of this code change. And these names has to match people that were in the team at that point in time. And then we just had a git commit hook upstream to verify that this was always specified. So we could have full traceability of which persons were always involved in the code changes. Another pitfall, which is not just about mode programming, it happens in pair programming all the time. That's one person keeps hogging the keyboard for a very long time, and the other person or persons gets bored after a while, engagement goes down, and it's not that productive. So the same thing in mob, and it probably gets amplified in a mob when you have 4 or 5 people waiting for having the keyboard. And we're all developers, we like to code, so we all want to be part of writing the code. So we solve this in a very easy way by just adding a timer. We tried with like physical egg clocks, but that was quite disturbing for the neighboring teams. So we found a solution just having a plug into our ID we could set to like 6 minutes. And when time was up, we just lifted the hands off the keyboard, passed it along to the next person, which helped us to keep engagement up. And if you know you're going to get the keyboard in a few minutes, you better be well prepared on where we are in the source code, what's the context, what we're trying to do. But I mean, it was a good start, but if you work from 9 to lunch and from lunch to late in the evening this way, it's quite exhausting anyway. And I mean, people have needs. Somebody needs to go to the restroom or fetch a coffee or so on. Sometimes you noticed when you had the keyboard that half of the mob was away for something else, and the other persons left there on your side, they were checking their phones or had their mind on something else, and that's not really mob programming. That's not really productive. That's you're just surrounded by a bunch of zombies, so I guess it's zombie programming or something. And that's not fun. That's not the point, that we are sitting together, but we're not working together. So we thought long and hard about this. How can we keep engagement up and make sure we're always involved, working focused on the problem? So we decided to use the Pomodoro technique. So if you're not familiar with this, it's essentially about dividing your workday into 30-minute segments where you work focused for 25 minutes on one particular task. And after those 25 minutes, you take a break. We go get a coffee or take a round around the block, get your mind off the problem. And then when you get back, you take another 25 minutes to either work on the previous problem if you haven't solved already, or pick a new problem, a new task to solve. And that, when we did that, we noticed that we could keep engagement up. Everybody knew that when we got into the mob, we could work focusedly on this particular task. We know we're going to get a break after 25 minutes. So then we can go make that phone call we need to do or get a coffee. So while we're in the mob, we work focused on this problem. But how do we remember all these great things that we agree upon? Sure, we're like, if we're a mob, 5, 6, 7 developers, always somebody going to remember stuff, but until it becomes a habit, a natural pattern, you need to constantly remind yourself about the things we talk about in retrospectives and how we make things better. So we decided to just print a checklist with all the different working agreements we had agreed upon and put them next to our screen, visible on the wall, so everybody could see it, so we could always remember the things we agreed upon. So this is an example of our checklist, which was quite simple. Half of the developers use Macs, half use Linux, but the Linux users weren't really comfortable working on a Mac, so we decided we want to make sure everybody who gets a keyboard and is start to program, they should be effective immediately, know the way around the IDE and stuff. They want to be comfortable. So we decided, let's just use the Linux computer. Everybody's comfortable with that. Let's use the same IDE, default key map, the same terminal shortcuts, and so on. So it can be productive as soon as you get the keyboard. We make sure to set the timer, take breaks, work focusedly, focus on flow, solving the actual problems when we're working together, and to have a lot of fun. So we worked with this for quite some time, and I think it was half a year later or something when we discovered something called strong pairing. I mean, it worked quite well with the timer thing and everybody got to be involved, but strong pairing comes from pair programming, which is about you having a driver, which is the person's keyboard, and a navigator, which is the person next to the keyboard, which is expressing ideas about how to solve particular problems in a high abstraction level, and then the driver just translates the spoken language of ideas into source code. So the driver just acts as a translator. You can think about this as a driver and a navigator in a car. So you want to get from here, from London to Birmingham, the navigator don't need to, in detail, specify for the driver how to shift gears, which lane to take, which car to overtake, and so on, or like how to operate the car. It's enough to say, okay, let's get onto M1, drive north for X 100 kilometers, then take this exit to get there. We can trust the person in the driver's seat to know how to operate a car or write Java code, otherwise we wouldn't put them there in the driver's seat in the first place. So like, the person who has an idea should not have the keyboard. And this was a big revelation for us. So we usually gave the keyboard to the person who was most confused about how to solve a particular problem. Or if I came from a meeting and hadn't participated for an hour in a mob, I sat down in the mob, asked like, where are we at the moment? What are the problems we're trying to solve? I just got the keyboard and like, hey, we're just implementing this API endpoint. We solve this problem. There's new classes here. We need to integrate this, and so on. And you don't need to fully understand everything that people says, but quite quickly you're starting to get the grasp of the problem you're trying to solve. But we're humans. We make mistakes. We had a few bugs during 1 week with some impact to our customers. So as a coach then, I made sure to talk about code quality on the next retrospective. And we noticed that, sure, we're really good at test automation. We automate all of our testing. We have no manual testing. But we're really not doing test-driven development as such that we're writing the test first. So we thought, okay, if we want to improve code quality, reduce number of bugs, maybe we should try TDD, do it strict way. So we tried that for a few weeks. And we noticed an interesting side effect, which was that when we started writing the test, we could make sure that everybody in the team were on the same page on what we were trying to solve, how, before we started to implement it. Instead of implementing something, and then when we write the test later on, people noticed, okay, but what about this corner case or edge case? We haven't thought about this. And then we need to do rework or re-implement. So we could set the expectations before we started implementing stuff. Here's a picture of how it looked like when we started mobile programming. So we just happened to have a lousy couch. We had a TV there. We just sat down and started hacking away. And we could fit 3 people there, tops 4 if you're Swedish, not more than that. So not everybody could fit around easily. It wasn't that comfortable either, to be honest. So we talked with our office manager to make sure we can sit in a good position throughout the work days. We upgraded to a proper table. Everybody could bring in their own chairs there to sit comfortably. So that was really nice as well. So make it comfortable. Not every team has that luxury of having their own team area, so many people start out in a conference room, for instance, and that's a good start, but it won't work for a longer period of time. And you're not going to be so popular usually because conference rooms are hard to come by at most companies, and people are going to get angry if you book conference rooms for full days and nobody's using the desks that the company has purchased. And we used continuous delivery way of working. So that's not at all a prerequisite for mob programming, but it worked really well for us. So we want to make sure that our source code is always in a releasable state, that we always can release new code changes. And we want to make sure that the whole delivery process is fully automated. So we can make low-risk changes all the time, so it becomes a natural pattern of deploying new code without any drama. So if you look at the previous picture on the top right-hand monitor, we have all of our continuous delivery pipelines fully visible all the time. So you don't need to log into Jenkins and click around to see what's the status of this code change. We can sit here, find a small incremental code change, we can push upstream, we can follow that throughout the pipeline. If something goes red, we get immediate feedback and we can fix that while we're in the context of that particular problem. And same thing if something goes through the pipeline, past all the gatekeeping, but there's an issue we didn't thought of and something goes haywire in production. We notice that on the top left-hand screen when we have our production monitoring. So we can quickly roll back if we see something fails. So we want to have fast feedback all the time. We also use the trunk-based development because we want to make sure the source code is always integrated and works. Then we have to work on master. If we work on a branch and do some testing there, as soon as somebody pushes something on master, it totally invalidates that. It's just a false sense of security. And to be honest, if we all work on the same thing, it's pointless anyway. Because, hey, we're just working on one thing. Let's just use master. So what are the benefits of mob programming? One of the main benefits is that it's always work in progress. It's like a bulldozer, constant progress forward. It doesn't matter if somebody interrupts us with a question, one person from the mob can just answer that. It doesn't matter if somebody is sick for a week or on vacation. People constantly know what's going on and work together and have some progress. The common misconception about mob programming is that you can't work in parallel. But you can work in parallel, but you're working on the same problem. So, for instance, if you're implementing a new API endpoint, and you need to carve out some new business logic, and somebody realizes that you're probably going to need a new SQL query here to get some new data set from the database we haven't used before. We're probably going to need that in 15 minutes' time. That person can pop up his laptop, start developing that SQL query, and when the mob gets there, everything is done already. Oh, now we need to implement that SQL query. We can just copy-paste that, run the test, see if it works, and then proceed. So we can plan ahead and work on parallel, but on the same thing. And we want to make use of all the collective brainpower we have in our team in order to create quality software. We want to make use of everybody's skills, knowledge, experiences. So I have a small example. In this example, simplified example, we have 4 core skills that we identified are important for us in our development team in order to create quality software. We write all of our stuff in Java, running on the JVM, so we have to know Java. We have to know test automation because we're responsible for everything that goes on into production. We want to have a good safety net, good confidence in the things we're delivering or working. We run all of our stuff on AWS, so we want to know some AWS in our team. And also, since we're on call, we don't need to have some ops skills. And it's interesting about the ops thing, like when you start to do test-driven development, you're going to structure your source code so it becomes testable. You're going to start working, structuring your code and designing it in a different way. The same thing when you know you're doing continuous deployment, like every code change to master is a potential release production. You're going to think about how this code change is going to be deployed. Do I need to hide it behind a feature switch, or what do I need to take into consideration, like health checks, metrics, and so on. So we need to take this into account. But if I have one person working on a particular problem, and which is a good Java developer, really good in AWS, but haven't really worked with TD that much, or doesn't have the ops skills, there's going to be some gaps here in the terms of quality that this person is going to deliver. So if you pair up this person with somebody who has great ops skills, for instance, it's going to get much better. They're going to cover almost all the aspects in order to create and deliver quality software. But if you add a third person who's a guru in Java and TDD, they will complement each other and make sure we cover all these different aspects. Another benefit, everybody can represent the team in a meeting. So sometimes we had a meeting and someone from the team needs to go to this particular meeting, then we could just decide in the morning who wants to go. It didn't really matter. It didn't need to be the most senior one all the time, for instance. And if fact is, most meetings were eliminated in the first place because decisions and discussions happened all the time when we needed them. We didn't need to, we need to have an architecture design discussion, but 2 people are away, so let's have it when they're back next week. But we couldn't find a conference room, so we have to postpone it a few more weeks, and then it's just a lot of waste waiting instead of just having everything going all the time. It's just constant knowledge sharing, and everybody keeps staying updated all the time. We even had persons leaving the team And we basically needed no handover. It was quite boring. Like one guy said, this is my last day in the team. Do you need anything from me? We're like, no, let's have lunch someday. See you. And the product owner was super happy. Because if you think about it from a product owner's perspective, you just want the top priority thing to be delivered as soon as possible. You're not interested in having 5 things being delivered a little bit every day for a week's time until they're done, because priorities change on a daily basis. So what's like the topmost or second most important thing today, tomorrow that might not even be relevant because priorities change, or there's a new thing popping up that has to go on top of the backlog. And it's frustrating if you have to wait for all these 5 things to be completed before we can start. So our product owner was super happy. Usually our Kanban board just had 2 swim lanes because we didn't need more. And if somebody tried to cram in a third thing, there was no physical space to put the index cards. We never worked solo. A common question I get is like, what's the optimal team size for working in a mob? We usually had between 5 and 7 developers in a team. We thought, for us, that can vary, of course, depending on your context, but for us, 5 was quite a good number. When we were 7, it was a little bit too much. So then we usually had a mob and a pair, but we preferred the mob. That was usually the most productive setup. We just decided each morning in that case, should a pair or the mob work on these particular things. Another interesting thing with all these agile software methodologies, we usually talk about definition of done, and that's really important to have a definition of done. I still end up in these discussions where something's done, or is it done, and nobody knows. So we realized that it's more important for us to have a definition of ready. When it's okay to start working on a particular thing? Because if you can't describe the problem, you will never find a solution to it. We want to make sure that everybody's on the same page about what the problem is, what user value it's going to bring if we solve it, how we're going to solve it, how we're going to implement it, and so on. So we're all on the same page where everybody can start working on it. We don't want the issue to be too big either. Like, we should be able to finish this within 3 days. Otherwise, it's too big. We're going to slice it so we can reprioritize and deliver as much user value as quickly as possible. And we don't want to be dependent on other teams as well, because it's really frustrating if we start working on something and after 2 days we notice, oh, we need something from a third team, and we have to wait for them, and we have to stall the things we're working on. So we'll make sure we have no dependencies on other teams before we start working on something. The real cost in software development is not about writing lines of code. It's about solving the problem. It's about all the waste that we have in our process, and it's rework. Those are the biggest cost factors. So with these concepts I talked about in this session, we were able to go from 12 tickets completed in our issue tracker per month to 50 without changing the ticket size. This was compared to when we worked basically solo before we started with mob programming. And we were also able to outpace the other teams in the organization in terms of how many deployments we did to production every day. So on a normal workday, we maybe had 20, 25 production deployments a day. It wasn't unusual that we're up to 60 a day. Just keep on working in the mob, identifying small code changes that could be isolated, pushed upstream, delivered, and just deliver stuff all the time. In our industry, we often talk about development teams. But the question is the development team which has a common goal, or is it just a group of people who happen to have this same shared interest? We felt like when we worked together like this every day, we really worked as a team, and we really had a lot of fun doing it. Thank you very much for listening.